Well, thank you very much, Frank. So with that, let me introduce our speaker today and reintroduce myself in case you came later. I'm Gary Birdcross, one of the co-organizers of this Ontology Summit for 2023, along with James Overton. And of course, the theme is trying to make ontologies and related semantic resources easier for research scientists and others who are not necessarily technical on ontologies, make these a little bit easy to use. So I'm very happy to welcome our speaker today, Adam Shepard, a colleague at ESIP and RDA. Adam works at Woods Hole in Massachusetts, where he's a technical director of the Biological and Chemical Oceanography Data Management Office, which is known shortly as BICODEMO, which was created in 2006 with the job of assembling, curating, and publicizing and serving all data and related products resulting from the NSF core grant programs for biological and chemical and oceanography, as well as the polar programs. BICODEMO provides limnology and marine chemical, biological, and physical data inventories from several large as well as intermediate-sized programs, as well as single investigative projects to support cross-disciplinary collaboration to address pressing environmental questions, problems, and challenges that are exacerbated with the increasing pace of climate change. So this is obviously of general interest and represents sort of another side of ontological topics from the domains of biomedical that we had earlier in the sessions. Of special note for today, Adam is founder and principal force behind scienceonschema.org, which provides guidance for publishing schema.org and adjacent LD form, making it easier for scientific use. Adam co-chairs ESIP's schema.org cluster and RDA's research metadata schemas group. He has several awards from Northeastern University, which is also Ken's alma mater. He lists his current interest in how semantic web technologies can help address science-driven use cases for next-generation research, all of which fits into Adam's and this year's summit's interest in empowering researchers who are addressing and asking questions about complex interdisciplinary questions, and by providing tools for improved data discovery leading to data use and new knowledge. And with that, let me turn it over to Adam.
Thank you very much. Welcome, friends. Thank you so much for having me here. Let me share my screen. Are you guys able to see that? Is it rendering okay for you?
Looks great.
Yes, indeed.
Yeah.
Okay, great. If you need it bigger.
Thank you.
Okay.
Very good.
All right, thanks so much. So yeah, my first foray into ontologies and semantics was from Peter Fox, who was instrumental in sort of taking our little research project at NSF and bringing us into that world. And so I feel, that was my entryway into that. But my interest in schema.org was also pioneered by Peter Fox's work, and primarily because of what we thought of as its usefulness in the community. And it was easier for us to see how our investment in semantics would pay off through schema.org. And so I imagine a lot of you already understand what schema.org is. But for those who might not, I'll give you my understanding of it. And I'd love for today just to be sort of conversational. So please feel free to interrupt me if you have a question or want to dive into a particular topic. I'd be happy to do that. I want to make sure that it's useful to you all. All right, and so for me, schema.org is really just a lightweight RDF-based vocabulary to describe entities on web pages, but not only the entities, but what you can do with those entities. And that was really intriguing to us as a data repository who was seeing the shifting landscape of the way that researchers try to find data. And so what we realized at BICODEMO was that while they might be coming to our repository if they know about us to search and find data, most researchers coming out of school are simply just wanting to Google and Google for things like, give me all the nitrate data in the Atlantic Ocean. And unless your web pages were well marked up at the time, you wouldn't be the precision and recall of that result set was not great. And so we were intrigued by the promise of schema.org to maybe improve that a little bit. All right, and so just from, I think schema.org probably was spearheaded by Commerce. And so I'm just throwing up here a page of something that you might find if you were searching for a hotel. And what's cool about schema.org is that you can describe all these little aspects of that particular hotel or that entity that you're trying to describe on a data set, or excuse me, on a web page. And so, there's tools out there to generate this markup for inserting it into the web page. And here we're just seeing all those fields that were in the search result as elements that you can describe using a tool like this schema.org generator. Okay, so for me, like I said, schema.org is about, web pages and how you inform search engines what your pages are about, the entities on them. But it's also, it's using schemas that are agreed upon by certainly the harvesters. And so that would be the consumers like Google and Bing and Yahoo, but certainly there's other harvesters out there. And that's what's really interesting about the scientific community, is that there's a number of initiatives that are interested in harvesting schema.org, and I might be able to show you some of those later. But essentially, what we're talking about here is schemas that are agreed upon by both these two communities, sort of the publishers of information on the web in the science community, and then certainly the harvesters like Google, Bing, Yahoo. But what's really intriguing is like what you can do with that content based on this schema.org markup. So, to dive into this a little bit, what is actionable content? It's great that you can compartmentalize this and build out nice looking search results. That's really cool. It helps your search users digest the information about what those entities are, but you can act on those entities, which is really interesting with the schema.org vocabulary. So I can initiate a hotel reservation. I can clearly click on the entity and view its website and read more, but there's so much more that can be done if described well. And certainly there's agreement by the publishers and the consumers, the harvesters, on what can and should be done with certain actions. So the actions can be unique to the content. And so it's not clearly just read this web page, but certainly with the hotel, you can build out a hotel reservation. And so the question for science was, what can we do? What are the actions that are important to research projects? What are the actions that are important to the outputs from those research projects, like data sets and research papers and the like? And so when we think about what that means for science data, especially for our repository, we see that folks clearly want to download data. They want to bring that data right into their tooling and build analytics and graphs and visualizations that help them understand that data. And then for searching that data, they love to, at least our community, since we're so geospatially bound, they love to draw on their specific geographic region of interest and find the data that's pertinent to them. But what else can be done? And that was something that really speared our community to sort of converge and get together under hoods like ESIP and RDA and sort of come to some agreements on how data repositories can consistently publish schema.org to describe research outputs. And that is really primarily driven by how those outputs can be used and made actionable. And so Science on Schema.org was founded. We admit that it was probably a little pretentious to go land grab that we're representing all of science, but we're a bold group, I guess. And so I get a little sheepish about it, but we went for it. And so we say that with all respect for bioschemas and the other initiatives in the sciences. I'm for that. So, all right. So the ESIP schema.org cluster is really focused on the intersection between your sort of web publishing standards like HTML, JavaScript, JSON, JSON-LD, and then schema.org, and how those intersection overlap the metadata work that's already being done at repositories. And so for a lot of repositories, that's DOI metadata, that could be ISO metadata records. In the geosciences, ecology markup language is another big one. And so there's all these initiatives that repositories already do. And we really wanted to understand how we can leverage all that existing work and make it an easy transition into the web publishing world, so that that rich metadata that already exists could somehow be leveraged and converted into schema.org, if you will. Okay, and before I go any further, I really want to highlight this paper that Gua and Brickley published way back when. And it takes the philosophy or makes the point that their approach to the vocabulary was that they wanted to make it easy for publishers. And by easy, what they mean there is sort of like leniency in how the RDF or the vocabulary is used or published. And so from my perspective, coming from like the linked data principles world and hardcore semantics, you want your publishers to follow the patterns strictly, and not have any errors, or else the sort of linked data principles fall apart, if you will. And so they took this sort of opposing view, not necessarily opposing, but a different perspective, that it should be easy for publishers, and that the hard work of interpreting what is meant on a web page when it's harvested at a particular date and time is really a job for the consumer, the harvester, to understand and reconcile what the meaning is of that. And so in one way, it makes it difficult to apply linked data principles on top of that philosophically, but it also gives the community a lot of freedom to make mistakes. It means that vocabulary terms can have content drift, if you will, and that might be acceptable because it's up to the harvester to understand and interpret, okay, when was this web page published and what was the state of the vocabularies at that time? All those types of interpretive ideas are really pushed to the harvester and are the responsibility of the harvester to undertake. But in this paper, they also argue that schema.org is just a core vocabulary and that it's meant to be extended. I'd say in the past 10 years, there's been a lot of interesting work done in that area from the publishers and curators of schema.org as well. They've dabbled a little bit in hosting extensions. But what we've heard from Dan Brickley, at least, is that reusing existing vocabularies right inside our schema.org markup is certainly acceptable and interesting to them, as they see more and more publishers of data use or reuse the same vocabularies. All right. So essentially what we've done, all science on schema.org is just a redirect to a GitHub repository at the moment. A lot of that is just based around the fact that we're all sort of volunteering our time and effort. And so we're just trying to keep the bar low so that we can continue and sustain this effort over time. And so if you happen to go to the repository, you'll see guidelines, examples, and issue queues for two concepts. One, describing data sets, and then also describing data set repositories. And we felt that having a description of a data set repository was particularly useful because of actionable content. And so that's because data repositories have capabilities, they have tools, ways of accessing data that we wanted to make sure that repositories could describe. And so search APIs, download APIs, and things of that nature. Let me just pause right here. And are there any questions at the moment, or do you want me to just keep rolling?
Well, there are always a lot of questions, but the point is the metadata for schema.org, do they contain the vocabulary terms, or is for example, these two things, data set and data repository that you are showing, are these part of the vocabulary, or they are subsets of these?
Yes, that's a great question. Okay, so our group at ESIP aspires to use classes and terms out of schema.org vocabulary, the core schema.org vocabulary. So we look to align what we understand about our data sets and repositories and map those onto existing concepts, classes in the core. And so these aren't extensions to schema.org. What you'll find is reuse of core concepts. And in some cases where we feel like it's necessary, we have published our own extensions, or at least we're trying that out to see how well it works. But I think a lot of the decisions behind that, and I can get to how we make decisions in a few slides, is really driven by, we want our data sets and our repositories to show up in Google for those researchers who are just going to pop open their favorite search engine and start typing science words, if you will.
Thank you. Yeah.
Yep. So that's the main driver.
Can I ask a follow-up question to that, or do you want to leave that till later?
Yeah, let's do it.
So one of the things I noticed with schema.org, you've rightly said it's vocabulary, and somebody involved with it once, Mirak Sopek, pointed out to me that it's deliberately polysemic, and this is absolutely right for the use case of schema.org. So if you've got a word like loan, semantically it might refer to the loan contract, a loan drawdown arrangement, a loan product being offered, and it is absolutely correct for schema.org that it is polysemic, but that also makes it not an ontology. And it concerns me when I see people refer to schema.org as if it's an ontology just because it happens to be an RDF. So I'm pleased that you've been talking about vocabulary and stuff. You're saying just now about linking concepts, and maybe you need to find some way of having like a layer, the vocabulary layer, pointing to the potential concepts in an actual concept ontology once you're trying to link to science, where you've actually got real ontological concepts framed in things like BFO and so on.
Yes. Yeah, exactly.
Am I on the right track? Cool.
Yeah, exactly. That was when this group started up. That was one of the biggest challenges is, okay, there's some of us in the community that already have made ontological commitments, if you will, to the way that we describe measurements and the parameters that were observed, how they were observed, what instrumentation they were used. And so this community was really cautious about, okay, how do we bring that level of detail into schema.org? And we can get into some of the challenges there. Like, okay, for example, if you're embedding, and we sort of promote the use of JSON-LD just because of its expressiveness over RDFA or other types of markup that are allowed for schema.org. So we promote JSON-LD. But doing that, certainly if you're embedding that JSON-LD record into your web page, you're increasing the page weight. And so the more that you say, the longer it takes your page to load, if you will. Certainly that's probably not a huge problem the further we get in time. But then, I think we've noticed at certain point, certain harvesters can only, or will stop reading a schema.org record at a certain sort of kilobyte range. So there's a lot of decisions that a repository or a publisher needs to make in terms of how expressive they want to be, what they want to put in that record, how big it is, and what the impacts are to performance and usability for your visitors, if you will. So that said, we certainly wrestled with techniques and landed on some that I can show you here in a minute if that's interesting to you all. All right, let's see. So yeah, just as a cluster, just some really quick information about us. So we sort of monitor the monthly schema.org updates, or at least they were monthly for a time. I think they've sort of shrunk down to maybe quarterly, and maybe it's even biannually now. We sort of accept all contributions and issues through our GitHub issue queue. We meet once a month, and I'll have the details for that later. And essentially all we do is maintain and publish an additional set of guidelines that are complementary to what's already at schema.org, the webpage. And so that dovetails nicely into like, why do we need these guidelines? What's the point if there's already schema.org, where you can go and view the vocabulary terms and concepts and just simply reuse them? Well, as we were doing this exercise back in 2014, we realized that at schema.org, these are very flat descriptions. And so you don't really have a sense of the interlinking relationships, the complex graph structures that are built when you're talking about a data set. Very rarely with a data set is it simply just the properties that hang off of that data set to describe. There's more entities like the people who did the collection or published the work, the instrumentation, the variables, so much that goes into it that the graph network that's built up to describe it is a little bit more complex than and hard to wrap your head around as someone that isn't familiar with linked data principles or concepts like RDF semantics and graph structures. So we thought like some type of representation that's a little bit more than the flat descriptions would be useful to a community that is embedded in data site, DOI metadata, and ISO XML records. And so on the schema.org website, there's very limited examples of how to publish this, specifically in JSON LD at the time. And so there's endless ways to publish. So you'll have concepts like variable measured here on the screen that can be represented as simple text, but also property values. And so we wanted to give the data repository community a sort of pathway to navigate why you'd want to pick a property value to describe a variable over simple text, and provide them examples as to that. And furthermore, we wanted shared publishing patterns so that we could federate a network of science data repositories that publish in a consistent, common way. And in doing so, we can then build validation tools for that community for them to test whether they're adhering to the guidelines or where they might be divergent. And that was primarily for our sort of novice users, certainly the folks that are embedded in linked data and vocabularies, ontologies, understand that stuff. But even still for them, it's primarily not the conceptual folks at these repositories that are implementing the work, it's software developers. And so we wanted to give that whole suite of people involved in projects like this some tools to understand whether they were on the right track. And a lot of that is because they're hoping for their data sets to show up at Google, but that's not an instantaneous thing. Certainly at a time, you would have to wait weeks on end to see whether your content was actually producing any value. And certainly Google's made it a lot easier to shorten that time to decision as to whether you're publishing correctly or not. So anyway, at scienceonschema.org, we'll produce a lot of drawings such as this, just sort of like conceptualizations that help people understand, okay, how are we thinking about what a data repository looks like? What classes are we using within the schema.org vocabulary to describe this? And then for a data set, we've got, a whole host of the data set drawings are ridiculously huge. And so we break them up into smaller categories and then provide links to concepts about those data sets that they can jump to as they need. These guidelines, along with the drawings, we like to put in code examples. And there's a bunch of JSON LD records in there that describe what we're talking about. And we provide prose, so some explanation as to how we landed on certain decisions, so that there's context for data repositories to map their own mental understanding of how they view their metadata into what we're describing, and then hopefully make good informed decisions about the best way for them to adopt the vocabulary. So just more drawings and more examples. Spatial coverage was certainly one in the geosciences that there was a lot of contention. And that was mostly around the fact that geospatial data is, at least in describing the spatial aspects of it, can get very detailed. Certainly the OGC guidelines, would say that you don't want to assume that you're always on Earth, which is nice for science. And I think Christoph Janovitz had a really nice example of that, where some science data was assuming that we're always on Earth, and their coordinate system for some lunar data showed that data being represented in South Sudan on Google. And so those are the types of sort of not mistakes, but errors that we don't want to have across all the geosciences. And so being able to describe spatial reference systems and the coordinates appropriately were really important to our community. And more recently, we published a tutorial that sort of walks someone through the concepts from soup to nuts. So what is JSON LD? What does this context mean in JSON LD? Bringing them along to just basic descriptions of a data set and introducing JSON LD concepts along the way. And so if you're looking at the numbered fields down the right-hand side, when you get to sort of number 11, we're layering on more and more concepts to increase the expressivity of records for these data sets here. And so that was an exercise that we undertook last year. So let me just get into a little bit of how the guidelines are managed, and then I'll check in with if there are any other questions. So as part of the monthly telecons, we use this technique called architecture decision records. And what we found with GitHub is that you can have issues, especially contentious ones, go on and span years. And so we needed a technique to sort of boil and condense all that understanding down to something that's digestible for someone who's coming new and fresh to the repository. Typically what's lost in these GitHub issues is, who are the voices of authority? How do you discern whether what someone is saying is valid or not? What's their standing in the community? And so these ADRs that we call them are the sort of governing folks, and literally all the governing folks are the people that show up to the telecons. It's those folks making decisions about how issues and topics are condensed into these short architecture description records. So like I was saying, we use our GitHub issue queue. I think there's about 80 issues open at the moment. We have a monthly telecon with a living agenda that is open and freely available to anyone there. Here's what these ADRs look like. And so it's made up of 4 sections. So a status on a decision, a brief description of that decision, any context that would help a new user understand where they can find more resources. And then finally, sort of the consequences that underlie the decision. So what's at stake between the opposing views and the various views surrounding a decision. And we've got about 12, probably a little bit more of those in our repository. And the picture on the right just sort of shows some of the issues that were large enough to require an ADR. All right, just real quickly, I just want to touch base with you folks. Any questions at this point before we move on?
Metadata, the .md means metadata.
Yes, yeah. So primarily what we're talking about with describing a data set is the metadata about it. Certainly there's ways to describe the observations and the measurements in schema.org, so that's certainly possible. Our guidelines don't dive into that so much because I think it's I don't know, actually. That's a good question. Why we don't. Maybe we should.
Well, Chris Mangal says it is down markdown format.
Yes, you can certainly describe schema.org using markdown format. We promote the use of JSON LD, or that RDF serialization of JSON LD, just because of its expressiveness. And certainly one of the issues that we have come into with describing data sets are things like item order. And so let's say if you have an ordered list of authors and you want to preserve that that author order, we think that's an important concept to preserve. JSON LD gives you a way or technique to present that where that's not necessarily as easy or possible in some of the other markdown or markups that schema.org lets you provide. And so that was just one of the challenges that came up as we had some harvesters in our community saying, oh, we noticed that the author's order it's not guaranteed that the order that you present them in the document is necessarily the way it's going to come out on the harvesting side. So yeah, that's a long answer to your markdown question.
So Adam, on the Zoom chat, Ronald and Wang had a question asking about whether there was any feedback or coordination of your efforts with repositories such as you see at NCBI. So any relevant work there that you've looked at or you know about?
That's interesting. No, I don't know if we've had any contact with anyone at NCBI, but certainly NCBI is a repository that is of great importance to our repository at BecoDemo. And so we'd love to chat with those folks and see if there's ways that we can coordinate and sync up. Yeah.
Maybe they'll come to your next session.
Hey, could I make a comment?
Please.
Oh, this is Wang Lin. Anyway, the reason I ask that question is because I work with NCBI staff a lot. Their metadata is a horrible mess. It just makes things very, very difficult to work with. So I'm wondering, I think your effort will, go a long way to help clean up their metadata stuff, because they only have like semi-structured fields. The people put in a lot of stuff they like into different fields. I mean, pretty much at free will. And if your effort can help them to make their metadata a little better, that would be great.
Sure. Yeah. Yeah. We'd love to have chats with them. It's almost like our data observations are metadata to NCBI. And so that's a really interesting use case. So yeah, if we could chat afterward, I'd really be interested in seeing who we might be able to connect with there.
Thanks.
Yeah, great. Ravi, and I think someone else has their hand up.
Okay, a quick one before Asya. The things that I see when you show us are more for the programmers, but are there things that you can show that are more for scientists? You did show data set types, 1 or 2 graphs, but can you dwell into 1 or 2 examples of where scientists are using this and how easy is it if they are not programmers?
That's a great idea. Let me just get through some of this stuff. We can come back to this. Okay, so, what's the point of all these repositories taking up this effort? As we started out, we noticed that our community was coming directly to us, which is cool, but they're just seeing data sets at BecoDemo. And so the researchers that are coming to Google and searching for data that way, we really wanted our network of repositories target that community. And luckily enough, this coincided with an effort at Google to publish a very specific search to data sets, their Google dataset search. And so as our project has been progressing, we've been able to monitor the results at the Google dataset search. And so the page that I'm showing here, I searched for nutrient abundance, and what is down the left-hand side are all the data sets that hit for those words. And the particular data set, the one at the top, is showing a data set that, interestingly enough, it's the same data set described at 2 different repositories. Well, they're not necessarily repositories, and there's a nice connection between the Arctic Data Center and Data One. But you'll find this across a lot of the data sets. And what's really great about this is that the same data set described in many places shows up once in these Google dataset search results. And I think that has helped our research community immensely. understanding the nuance or differences between what might appear in repositories, and it gives them a sort of certain level of confidence that they can rely on Google Dataset Search to sort of find where data sets might be, and maybe even complementary metadata across those repositories. And so this is what Google's done for this particular schema.org record. It's pulled out the DOI, who the provider is as Arctic Data Center. So that means that data one is just sort of like a republisher, if you will. It's pulled out the author name. And then interestingly enough, the geospatial coverage described in that schema.org record was good enough for Google to confidently put up a map. And clearly we know nothing about what Google's doing behind the scenes. We've talked to those folks, but they're pretty protective. So we treat it as a black box. We'll just publish out schema.org records as best we can, and we're at the mercy there. But efforts like Data One, who is also a schema.org harvester, can do more with those records. And so with our guidelines, efforts like Data One and another can do more with that. So here's just a list of some of the folks that we know of that are publishing schema.org records. I think this list has certainly grown since this slide was produced. But here's an effort that is a global effort that is mostly adhering to the Science on Schema.org recommendations. And this effort coming out of UNESCO is called the Ocean Info Hub. It's led by Pierluigi Buttigieg, who I'm sure this community is familiar with. And one of the drivers here to this effort is to answer some of the sustainable development goals coming out of the UN. And so if someone was to ask, what are the carbon rates across our oceans? Ocean Info Hub is at least aspiring to answer, to connect the concepts and entities in a sustainable development goal to the parameters observed in a particular data set. And so they've built this little tool here, harvesting schema.org records across a global set of repositories. And so this is really exciting. At the very least, to identify where the gaps are across repositories. And I think Pierre would say that that's a good starting point for at least beginning to address how we might answer one of those SDGs. Yeah, I'm sorry.
Good example. Good example.
Yeah, great.
Asia?
Yeah, okay. So my question is more following on Ronlin's question. So you said that NCBI's data set has horrible metadata. Can you tell me the exact databases that you're talking about, or you're just talking about in general?
I'm talking about NCBI Geo. This is a database. This is a repository for all the gene expression data stuff.
Okay, I see.
They contain metadata with semi-structured fields. People can dump in all kind of free text into those things. You can't search them. You have to do it by hand.
I understand what you mean. Yeah. Okay. Because NIH has so many databases, and this is also a question back to Adam. So the things that you just showed is more like describing the data sets, metadata to describe data sets. And then if you add a science on it, so the whole science on schema.org thing is to create metadata to describe data sets.
Yes.
Is that correct? Okay.
Yeah.
I think I don't know. If I find some chance to plug you into the NIH group, I will. But I will join your call because we are developing a data catalog, and the group is using schema.org, but they don't know about existing of this one.
Okay.
Yeah.
Great.
Okay, thank you.
If there aren't any other questions, I'd be happy to, and I see there's some things in the chat, I'd be happy to show you how we've sort of incorporated other ontologies, dealt with geologic time or deep time. Happy to use the rest of the time however you all see fit.
There was a
Adam, do you
question
have
in the chat
more
by,
material?
by Nancy.
Do you have
Nancy
more
Wiegand had a
material
check.
to present?
I do have other slides, but nothing totally compelling. So I'd prefer to just sort of answer questions if that's useful. Yep.
But Gary,
As I was saying, Nancy Wiegand has a question in the chat. I can read it, or she can say more about it here. What level of
Very good.
detail can be asked with schema.org when applied to a science data set? It's question mark. For example, for a hotel, you can inquire about hours or reserve a room. For soils or ocean, whatever data set, how low a level of question can you ask? So it's a detailed.
That's a great question. Certainly it depends on the way in which repositories have published out their content. So for example, if I clicked on just sort of a walkthrough on variables, schema.org lets you just put in text for describing the variables. We have no idea of whether the variables are in the right order. If we're talking about a tabular data set, we don't really know what these variables are in terms of other vocabularies. And so a better way to publish a particular variable is to use this property value type in schema.org, where I can at least say, okay, here's the name of the variable and here's a description, and there's other fields that can be described. If I wanted to say bring in other vocabularies, I could say here's the variable name, its description, and then here's a URI where you might be able to find even more information about what this observation means. We can even describe units and codes for those units. So URIs into, let's say, QDDT or UOM or other unit vocabularies as possible. And so this just gives folks an understanding of what can be done, and in terms of incorporating other vocabularies. Certainly there's other strategies that you could use. So the @ type is, synonymous with the RDF type predicate. And so you could make this an array of types, if you will. That's certainly one technique. Our group just sort of landed on using property ID for that. Some of that decision was really based around the harvesters and in turn, and trying to interpret the @ type as being a schema.org class. But then again, for me, maybe some folks in the group might not agree, but I always go back to Guillaume Brickley's paper that it's up to the publisher to make it easy and lenient for them, and it's up to the harvester to interpret. So anyway.
So do you have an example though? Are there some data sets that are marked up well enough so that you can ask something specific and get an answer? Or are you still just dealing with very high level finding the data itself?
Yes, yeah, that's a good question. So there's other things that you can do to describe sort of the APIs that are provided for a data set, and that would be in the repository description. I could show you how publishers can use that stuff, but ultimately it depends on the harvester and the way that they represent that information that would make it actionable or not. So I don't know of any examples at Ocean Info Hub that are using action. There is a group at NASA that is interested in this idea they call smart handoffs. And so what they're trying to do is they've got one website for searching across data, but they have multiple DACs, or data access centers, they call them, spread across the country. And those DACs have different services. And so what they're looking to do with schema.org is on that central sort of search page for a data set, is when someone clicks on a result for a data set, hand off to the DAC some of that metadata from the schema.org record, or from the search even, to give that data access center some idea of what the searcher was trying to do with that data set. And so, for example, let's say that researcher is looking for data sets that were only collected in the summer months. That information from the search would be passed off to the DAC to then do something else with it. But I don't have any concrete examples of anyone doing anything actionable like a hotel reservation for data sets yet, outside of
Adam, what you just described is great, because I was involved for 3-4 years along with Dr. Ramapriyan, Karen Moe, and others in setting up many of these DAC structures.
Yep.
And as you were showing me the ocean depth of the complete scope of ocean thing, I was thinking, how would I integrate metadata from those DACs? For example, JPL's physical oceanography DAC is important for oceans. So how will I combine that with the recent ocean set data from other countries, and also those who go in situ with buoys and others to get coral reef or other kinds of data from in situ? How would I integrate them for a UN project of, let's say, ocean recovery or pollution in the ocean or something like that?
Yeah, that's a great question too. It would be great if Pierre was here to answer that, because I imagine he would have a vision for how he expects that to happen. My guess would be that with the Ocean Info Hub, and I believe they do have guidance on how to describe the instrumentation, the deployments, the methodologies that were used, so that if there are repositories globally that are publishing that information, they could do a faceted search that lets you specify, hey, I only want data that was collected by this particular instrument using this methodology in this particular sea area, and the Ocean Info Hub would be able to return that back. That would be my guess. I would imagine that's what he's driving towards. Some of the challenges, I skipped over the challenge slide, but some of the challenges that we've seen in the geosciences is that the schema.org core vocabulary doesn't really have great concepts for describing vehicles, instrumentation, and connecting that in a way to a data set that allows you to express the methodologies. And so I think that's a case where ontologies like SOSA and SSN become really useful, because it gives you those conceptualizations and does it very well. Then it becomes, okay, well, what's the cost of putting that into my schema.org record? And is it going to get used by Google? So oftentimes I think, at least what we've experienced, is that you really need a harvester to kind of step up and say, hey, this is what we want to do. This is what we're going to do and commit to. And then that sort of gives the publishers the confidence, like, okay, well, it's worth going through the effort of mapping my metadata to something like SOSA SSN or some other extension. And so that's why it's great to have Ocean Info Hub and someone like Pierre sort of stepping up and providing a vision, because it gives those publishers some confidence.
Before I yield to my chair here to Gary, last question. How far you think you are conceptually in reaching from Ocean Info Hub to ocean science related ontology solutions?
That's certainly a question for Pierre, so I wouldn't want to speak for him, but my uneducated guess would be that we're still pretty far off. I think my repository and others in the oceanography, limnology fields are starting to converge on some common vocabularies. And so that's great. A lot of them, we're using concepts out of Kebi and Pato and other vocabularies in the Obo Foundry. Those are great resources. Envo, obviously. And then there's the NERC vocabulary server hosted out of the British Oceanographic Data Center. And that's been sort of like a more globally adopted resource. And so there's been some efforts to map NVS to Obo concepts and other vocabularies like, oh gosh, what is it? Climate and forecast, CF standard names. So I think we're getting there. it seems like it's happening really slowly, which is understandable, but I really think Pierre's effort here with Ocean Info Hub is going to be a great exercise so that when someone asks Nancy's question of Ocean Info Hub, and we can at least show the gaps and where we need to start honing our focus.
Thank you. Thank you.
So Adam, this is Gary. I had a question from, I put in the chat also. I didn't want this session to go to end before asking the obvious question of what, if any, relationship does this Science on Schema.org will have to something like Wikidata, which we had a session on a little bit, a couple of weeks ago.
Yeah.
Is there anything you've looked at, and is there anything happening there?
Yeah, that's a great question. You know, there's a lot of talk amongst the members of our group of reusing Wikidata entity URIs to identify certain concepts. And so, you know, Doug Fills in our group is one who's really interested in that idea. And I think that idea has a lot of traction just because there's so many entities described in Wikidata. So yeah, I'm not sure if any efforts have been funded to explore that any further, but it seems to me that there would be a lot of promise in that. Yeah.
And a follow-on question, also before we end, is are you aware of any uses for this to help build knowledge graphs?
Yeah, in fact, I think this oceaninfohub.org is harvesting and putting all their interpretations into a graph. I think Ocean Info Hub is built on Blaze Graph. Doug Fills is also involved in that effort with Pierre. And I think they've been looking at other cripple stores that might have, you know, a better chance of living beyond Blaze Graph. I think it's now turned into AWS Neptune. I think they've gobbled it up, but anyway, yeah. So I think it'd be great to see what Ocean Info Hub does with their knowledge graph and connects to other graphs like the NERC vocabulary graph. Certainly our BICO-DEMO graph, we'd love to have connections and federation into Ocean Info Hub. So there's certainly a lot to explore there that I'm excited about.
Well, I know Pierre, and he's very busy, obviously. I'll ask him if he can be part of our panel next week and maybe follow up on some of these questions.
Sounds great.
Thank you, Gary. Great talk organized. Thank you, Adam.
Thank you all for having me. Appreciate it.
If there are no other questions, then we'll adjourn for today. And next week, we have sort of a second panel. Some people are unavailable who earlier thought they'd be part of it, but we're still working on it. We have 2 or 3 people who are going to be at least part of it, and Link ML will be presented, which came up in a prior session as something that maybe helps bridge from the Obo Foundry realm to other realms and could be of common interest. So we'll hear more about that next time. Okay, I don't have anything else. Anybody else have a final thought or question? If not, we can adjourn for this time, and hopefully we'll see people next week.
Thanks, Gary. Thanks, Adam.
Thank
Frank
you.
has some last minute things in chat in case people want to make a copy of the chat before going. So
I'll be
okay, thanks,
posting
everybody.
them in the meeting page.
Yes, great. Thanks very much.
Thanks a lot. Thanks. Bye.
I know.
Take care.
Bye all.